So in this specific problem, we balance the chemical equation, we do some stoichiometry, and then we use gas laws in order to answer the question. So truly multidisciplinary. Gas law, stoichiometry, and some equation here. So methane, the principal component of gas, is used for heating and cooking. The combustion process, anytime you have a combustion process, you yield CO2 and water. So we got 15 moles we're starting off with, and what is the volume of our CO2? So remember, CO2 is our product. Produced at this temperature, let's convert it to Kelvin, so 273 plus 23 is 296 Kelvin. This pressure, 0.985 atmospheres. Okay, so what are they asking here? Volume. Okay, so they're asking for the volume that's going to be produced. So what I would do is, we're starting out with 15 moles of methane. We got to figure out how many grams we get from the balanced chemical equation. Actually, we can figure out how many moles we get from the balanced chemical equation. And then from there, we plug it into the ideal gas law to get the volume. And just by looking by eye, it looks like this is already balanced. 1 carbon, 4 hydrogens, 4 oxygens, 2 oxygens here, 2 oxygens here, 2 plus 2 is 4. So even more simpler. We just use stoichiometry and then the ideal gas law. So let's go ahead and do this problem. All right, so got my equation here. What is it? We have, 15 moles of CH4, and let's figure out how many moles of CO2 we get out of that. Equation is already balanced, which is good. So start with 15.0 moles of CH4. You start with what you're given, and this is already balanced, so that I think this is a pretty easy problem. For every 1 mole of CH4, because this is already balanced, we have 1 mole of CO2. So we have 15 moles of CO2. All right, so PV equals nRT. This is an easy problem, easier than I thought it would be. So we got this temperature, we went ahead and converted to Kelvin. We got this pressure, we got the number of moles, which is N. All we got to do is solve for volume V. So solving for volume V, nRT over P. The N here is 15 moles of CO2. Thought this would be a lot harder. R is the ideal gas law, 0.0821 liters atmosphere divided by mole Kelvin. And then T is, did they tell us the temperature? Yes, they did. The temperature is 296 Kelvin. And P is, did they tell us the P here? Yes, they told us the P here is 0.985 atmospheres. All right, so moles cancel, atmosphere cancels, Kelvin canceled. I am left with liters. So doing this on my calculator, actually 370 liters. So that's the answer to this problem. Stoichiometry, using the balanced chemical equation to get us moles, that's going to be N, and that's the N that we're going to use here to solve for volume in our ideal gas law.